Good morning, everybody. We will get going in just a minute. In the meantime, I really could use some note takers if anybody is willing to take notes in the note-taking tool. Yeah, so that would be fine if presenters want to do some swapping. So Thomas, can you take notes while Raphael is? Okay. And multiple people can help. The note-taking tool is very collaborative. You can type over the top of each other. So it's actually very helpful to have even a couple of people. And really, we need action items and things like that, not verbatim conversations in the first place. So we don't have ChatGPT yet working. No. The transcription system used to. Do we have transcription now? I guess that went away this time. It was an experiment last time. So. We should probably go ahead and get started. You can, yeah. The note-taking tool makes it a little bit easier to do collaboration so that other people can help. But whatever works, it will accept notes in any form you can get them to us. So to start off, I'm Wes Hardiker. Claire is my wonderful co-chair, and she'll be speaking in a minute. And yeah, Claire, do feel free to go ahead and broadcast your video as well. I will say that there is, one of the most important things that we can do is make sure that you do sign into the room. There is a QR code, which will appear when Claire goes away. So the screen over there will have a QR code on it. There's one outside the room, and you are welcome to scan this one as well. Yeah, the downside of our audio-visual system is that the QR code only appears when nobody is on video. So, but everybody do please sign into that, because that is our official record of keeping track of things. I'm sure most of you have seen the note well at some point in the past, but you should make sure that you understand it well. By contributing to the IETF and by participating, you agree to follow the IETF processes and policies. That includes intellectual property. It includes the fact that you'll be recorded for video and audio and things like that. If you have questions, contact your lawyer, because I'm not one. There is a number of things that the note well covers. There is a list of best current practices in the IETF for those that are newer to the IETF. These are all worth reading. They include how the standardization process works, how working groups work, our anti-harassment and code of conduct procedures, which we follow very strictly, how our copyright system works, and how patents and participation works, and how you must disclose them when you're contributing to the IETF, as well as our privacy policy. Our IETF Code of Conduct guidelines, which I have an explicit slide about. These are important. We treat colleagues with respect. We speak slowly and limit the use of slang. This is where I fail a lot of the time, so I will try and slow down. We dispute ideas by using reasoned argument, and we use our best engineering judgment. We find the best solution for the whole internet, not just a segment, not just my personal view, but we really need to think about, what's the best solution for all the users of the internet. And we contribute to the ongoing work and the group of the IETF. I'll remind you that this session is being recorded both visually and in audio. So make sure, as I said, you sign into the session. You can use the QR code that I mentioned. There is also links on the IETF agenda, regardless of whether you're using a phone or whether you're using a computer. You can actually log into the session that way as well. We do use that Meet Echo tool for doing all microphone queue management. So you need to hit the raise hand button on the little tool in order to get into the queue, and we will follow the ordering in that queue pretty strictly. keep your audio and video off unless, if you're using, if you're in the room. If you're remote, keep it off until it is actually your turn to speak and present. Remote participants, make sure, as I said, keep everything off, and, making sure your audio is good by using a headset is, of course, well recommended. This is the information about the working group in particular, the SAT protocol. We have a data tracker that has lots of our information and documents. We have a mailing list, which is actually SAT, not SATP, because it predates the name of the working group a little bit. And there are 3 active working group drafts to consider, and those are actually the old name of the drafts. I apologize for not updating this slide. They're all now draft, IETF SATP with core architecture and use cases. Those will get you there if you search for them, though. Our working group meetings, we hold them at every IETF. We have monthly interim meetings that have been very well attended with good discussions. There are 2 more coming up, one in August and one in October. Why don't we have one in September? And the other question I realize is that, we planned a bunch of these out. We haven't talked about continuing. My guess is that we probably want to submit a bunch more. Claire created them all in the past, and Claire, I think you and I probably need to chat about, creating ones for November and beyond. So we'll add that to our to-do list, because those do seem to be an effective way of communicating for this group. This is the tab-damaged version of the agenda. It looked much better when I looked at it on my screen. Welcome to PDF creation out of something or other. There's a lot of things on this agenda, and I'll see if I can find a better copy of it at some point. But the important things is the agenda items in the beginning, especially 3 to 6, are core working group items. The things under any other business really fall to things that we know the working group wants to do at some point in the future, but are slightly out of charter now, even though they're somewhat related. So we do give priority to items 3 to 6 in particular. So if they need a little bit of extra time, we'll actually sacrifice any other business, and we apologize for that being the case, but we have to get through our chartered items first. With that, I'm going to turn it over to Claire, who is going to talk about the scope and the purpose of the SAT working group in the first place.
Absolutely. And to the point on the previous slide, as I'm remote, I have the advantage of being able to be the stopwatch. So we'll give you sort of a 5-minute warning for the presenters. If we go a couple of minutes over the 5 minutes, fine, but we do need to be fairly consistent with the times that we've put forward. And whereas I've just double checked the meeting agenda, we do have a meeting in for September the 12th as well. My apologies, I missed updating that on the slide. Hi everyone, thank you for coming. Sorry I can't be there in person. The Atlantic is quite a large ocean to cross. So without further ado, the scope. So we've all had this before. I will just repeat it again for the benefits of framing conversations for today. The focus for our first iteration is to develop a protocol for the secure single one-direction unidirectional transfer of any digital asset between any 2 networks. So you will hear a lot of talk about blockchain today, but that's mainly because a lot of our presenters are focusing on that area. But any solution we come up with will be agnostic to any network and any digitalized asset. As to the focus of our documentation and the focus of our work, it will be for the transfer itself between 2 gateways. So there's some assumptions about the setup of a network and a gateway. The discussions around a gateway, what a gateway contains and what a gateway can do, should be limited only to the elements of that gateway that will impact the transfer of the asset itself. So only so much in that messaging might be impacted, recovery might be impacted, and beyond that, that's out of scope for this version. Any questions, always bring it up. We're happy to discuss and agree as a group whether or not it is always in scope, but we do need to focus on the scope first. Thank you, Wes. Next slide, please. So, as I've just said, unidirectional asset transfer, gateway to gateway asset transfer, assumptions about the networks. It is agnostic to all of them. Future scopes to be confirmed, multi-directional, gateway considerations, digital objects like bills of lading, and then in networks itself, so pre-locking, which I know we've got some agenda items today, but only insofar that they impact the actual transfer itself that we are discussing. Thank you, Wes. Next slide. I'm not going to keep reading the slides out to you. I think we've made the point. In terms of path to adoption, we are here. We have been formally identified as a working group. We've had our first official working group meeting. We've agreed to formally adopt all 3 of our documents, as Wes has pointed out. We're now in the design and deliberation phase. So we have the interim meetings, the mailing lists, documents are being edited and revised by the working group. We're in that process now. Once we've agreed that the documents are ready to review, they go out to a peer review and feedback, and the edit and review cycle will continue until peer review is confirmed, and then that is the documents on the path to implementation. So just to kind of point out where we are in the cycle, still very much, as always, will be a collaborative process. All ideas are welcome for review and discussion. I think that takes us to our first 10 minutes, bang on time. Thank you.
It does. All right. So we'll ask Thomas to come up first and give a presentation on the update to SAT Core. I will run the slides. Yes.
Morning, folks.
It's all yours.
Okay, thank you. So this is a set of updates that has been done to now called Core 2. And some of this was discussed at the last interim meeting, the online meeting, but I thought let's go through it again in more detail. Next slide, please. Thank you, Wes.
I was hoping this would work.
Okay, so basically 4 bullets and a quick report on the architecture draft. So these are the main set of changes, groups of changes, and I'll go through each one of them. And there's a red sort of notch on the right-hand corner that tells you we're moving to a different topic. Next slide, please. Thank you. So the first thing is removing the redundant ACK prepare. So thank you, Alex. I think Alex is online somewhere from the UK, but thank you for pointing this out. So in the classic 3-phase commit, for those who remember the database class, there is one coordinator and multiple subordinate databases. So when you do a change on one database, you want to propagate it to all the other copies. That's the whole point of a distributed database. And so when the coordinator sends, get ready, prepare to commit, all of these guys, or a majority of them, have to actually explicitly send back an ACK acknowledgement. Yes, we've received this notification, we're ready to go ahead. But since we are only dealing with one sender gateway and one receiver gateway, not a one-to-many, this particular message is redundant. Like, what's the point of this one single recipient gateway acknowledging something that both sides already know it's going to happen? So that's been taken out. And so so you'll see in the for those who are interested in the details, the message flow diagram, there's a link before to our GitHub repo, and the current gigantic color diagram is version 19. You'll see the ACK prepare message still there, but grayed out. And when we move on to the next rev, that's going to be taken out completely. That's kind of our habit in the group, is keep the messages that are going to be deleted or changed in gray. And then you see the next rev, it's gone. And all the revs are there up in the repo. So if you want to go through all the way to like version 7, I think it's up there. Next slide, please. So this is what it looks like. Commit prepare is message 3.1. And you can probably see it there. Yeah, you can see it, right? It's gray. For those who are not familiar, it's the gray arrow going from right to left, ACK prepare. And so that's basically gone. It's worth noting, we did discuss cases, well, in the future, what happens if you have an asset that's going to be split into 2 and there's 2 recipient gateways, and we kind of said, no. Let's just do the basic first. If you can't do one-to-one, then there's no point arguing about one-to-many. So this is where it is at that point in that diagram. Next slide. Thank you. Shall I do it? Oh, thank you. Okay, so transfer commence. So because of that, we also thank you, Alex. Well, really logically, so there's 3 stages. Stage 1 should organize the setup, and so the agreement to commence really need to happen in stage 1, and all the other stuff like locking assets in stage 2. So what has happened is 2 messages have just simply been shifted up to stage 1. It used to be at the top of stage 2, and these are called transfer commence. Let's commence, and the other side says yes, acknowledge, let's commence. And so, however, the other thing that we did for stage 1 now is so you'll see message 1.3 and 1.4 used to be in stage 2. Now it's part of stage 1. It's just been shifted up. So it's just a logical, the way our mind sort of, arranges things. But the big thing also that we added is this multiple negotiations of the features of not only the gateways, but also the assets. So we call that transfer claims. So this is gateway G1 saying to gateway G2, these are the parameters of the exchange. And G2 can say, yes, I accept that, or G2 can say, no, I don't like your signature algorithm. I want to use a different signature algorithm. So it goes back again. So that loop, that dot arrow thing is trying to say that this is a multi-round segment. So 1.1, in fact, is multi-round, is really what we're saying, right? And so, and we've just been calling that transfer proposal claim. Right now, if G2 accepts the claim that is just received from G1, it simply sends a receipt message. So when you hear the word claim, it's a digitally signed claim that's independent of the SSL, the TLS connection, so it stands alone. If you see a receipt, it's a signed receipt. Why do we have to explicitly sign stuff? Is because there's legal and financial obligations when things go wrong, when disputes occur, and so both sides need some kind of a standalone evidence, and which is why they have to digitally sign stuff. So 1.2 is the explicit receipt. Now, if this round thing keeps on going on and on and on, and G2 finally gives up, okay, I give up. This is too hard. G2 can simply send a counter proposal with an empty claim. I give up and terminate connection. So this is one mechanism, and we're looking for ideas for different ways to gracefully indicate that none of these claims, or majority of these claims, is just not acceptable, and so we want to terminate. That's another future sort of subject that we want to broach and address here. Any questions before I move on to the next bullet change?
Please do use the Q button if possible.
Ned Smith, Intel. So I think it's not clear whether transfer protocol receipt is continuing the exchange. Otherwise, if it's terminating the exchange, then it's not clear what message is being sent in the dotted arrow. Okay. Should give it a name.
Okay, thank you. That's exactly what the input we're looking for, because trying to show this multi-negotiation and final receipt and reject in a diagram. But yeah, so if folks have suggested names for this, we're quite open to names. We're kind of struggling with names.
Thank you for that. And Yaron, so I hope that's pronounced right.
Hi, I'm new here, so this may be a silly question. Yaron Sheffer. We, in many network security protocols, we have avoided multi-negotiation forever, basically. Why is it justified here? Why is it needed here?
So thank you, Yaron. Nice to see you. A long time. We have a stage 0, actually, that's out of scope. And Dennis is going to talk a bit about stage 0, which is the setup. So we have the same question has been asked of us. Well, why not do all this stuff about what is the asset type and all this stuff really need to be stage 0, out of scope for us. So it's quite possible that 1.1 and basically 1.1 is just, they've already agreed somewhere in stage 0, it's out of scope for us. And 1.1 just says, this is what we agreed upon, sign it. Yeah. So originally the previous version, 2 versions ago of this diagram was just a simple, this is what we agreed upon. Yes. I agree. Yeah. Thank you. Yeah. So this is, if you have some thoughts and you want to help out here, Yaron, I know you're capable. I know you're a busy guy, but yeah, stage 0 is this sort of complex, because a lot of the stuff out there is beyond the IETF. For example, identity of the originator and beneficiary, like who are the, how do I identify gateway operators? Right. these are
Two quick points with respect to the IETF-A. This is the exact type of feedback that we want in the IETF. We actually want an interactive discussion with feedback. That's the purpose of this. It's not a presentation just to, so we like questions. But,
questions.
Two, the SAT protocol working group had a very restricted charter to get started, where we scope things down to just this interaction and deliberately put out of scope things like the agreements that had to be in place first, as well as how gateways might interact with their community. That's stuff that we want to do in the future, but the charter, you know, we didn't bite the whole problem at once. Right. So thank you very much for that. Yogesh?
There's a question from Yogesh.
Hi, I'm Yogesh. Probably a naive question as well. So are we assuming that the two gateways are online all the time in terms of connectivity?
We hope so. I'm assuming yes, and that's why we got Raphael. So the model we're adopting for crash recovery is a primary backup. So each side actually has a shadow gateway, right? And so if it dies, it's going to pick up the session. And so this topic, we put it under the title session resumption, which is actually turning out to be quite complex, actually more complex than I thought. And that's why we've got Raphael here. Yeah, good. Thank you, Yogesh.
Okay. And then Ned again.
So one way to approach the recurring negotiation protocol is to define a state machine. So for example, if you've established that you have a set of claims that you've accepted and a set of claims that are not accepted, if you create a state machine for each of those claims, then each side can check that that the state machine is progressing.
Is your right hand volunteering? No.
Maybe.
Maybe. Yeah. No, this is great. We actually did the state machine kind of thing for the asset states, but not for the stage 0. Yeah, no, that's a good idea. Yeah, that's a good idea. I think Dennis kind of is saying the same thing for stage 0. Right, Dennis? You can just type yes.
Absolutely. Yes. Very nice. Thank you.
Thanks, Dennis. Okay, so moving on. Next one. Okay, so this is the set of claims. So in the previous version of the draft, it was disorganized. Let's just put it that way. And I said, look, okay, let's just put everything in section 7. So section 7, has multiple subsections, but there's one specifically on the claim section pertaining to the asset and the actors, meaning what is the asset profile? What is the identifier for the asset profile? What is the identity of Alice and Bob, right? So that's assets and the actors. And then a second set of claims has to do with the gateway itself and the network itself, or the characteristics, because it could be, for example, network 1 might be using a different duration lock. It might be using an escrow instead of a lock, right? So it's just grouped that way just for us to easily understand, the sections. It could be that, as Yaron was saying earlier, that all of this stuff really needs to be in stage 0. Right. So for example, a gateway, this is a good one that I think will come up when we talk about session resumption. Should G1 indicate to G2 its primary backup, the identity of the primary backup, so that if one of them crashes and they want to do session resumption, they're not surprised. They know who to expect as the primary backup gateway. Right? So things like that. But this is in section 7.1. It's super drafty. So, please take a look at it and, edit it. And maybe all of this stuff really could be separated into like a separate draft, because much of the item there is out of scope for the IETF. In fact, it's driven by business logic. It's driven by government policy, regulation, is really all the stuff in stage 0. This is just some examples that we have now: the digital asset ID of the asset, the profile ID, identifier of the profile file, verified originator identity. So the word verified is there to indicate that this is a big topic, by the way, in the crypto space, that entities who run services like gateways, they're almost obligated to make sure that the identity of Alice, the originator, and the identity of Bob, the receiver beneficiary, is known ahead of time. This is the famous travel rule, which came out of the the BSA Act of 1996, public key. So this is just you guys should not be surprised with this. This is just me compiling everything into one section, and more is needed is really what I'm asking you guys about. So, so this is definitely, this particular topic section needs a lot of work for the core draft. Next slide. Session resumption. So we're gonna hear more about this from Raphael, but the general idea is we would like to have a message flow that it basically says, from one sender, from G1 to G2 or vice versa, request session resumption, and then there's another line flow going back saying, yes, no, here are the parameters. But what is interesting is there's a lot of machinery that's happening behind the scene, behind the gateways, and that determines, well, there's a recovery sort of architecture that's going to drive the selection of the parameters. That's going to drive the primary backup gateways. So I'm just putting this as one slide, basically saying, hey, look at the draft recovery 0.0, and I think this is going to be the topic. We're going to spend like half an hour with Raphael later on. So this is new. I think I just posted this on Sunday as soon as the upload website was available. So the architecture draft now matches the flows in the SAT core. Previously, SAT core was like 2 versions ahead of the architecture draft. And there's thank you, Rama, for putting in a lot of text on the ISO 222. For those who are not familiar, that's a gigantic set of messaging standards for the banking community, and we think like we should be using that for stage 0 because it's there. Some people might not like XML, but I don't mind XML, it works. So stage, we're looking at, well, what messages could we pick out of the set that we could apply for stage 0.
Just to interrupt very briefly, 5 minutes remaining.
Oh, thank you.
Thank you.
Is that the last one? So next step, I think this is my last slide. So we're going to continue working on the Raphael, on the error messages section, and definitely work on what to do with this set of claims, and then any other topics, fixes, corrections that you guys want to make or introduce into the draft. I think that's it. Yeah. Okay.
So with that, are there any questions to the room, either remote or in person, for Thomas before we switch context to the next agenda item? All right, seeing none, I think we'll move on to Rama.
Okay, thank you.
Give me 1 sec before it works.
Good morning, everyone.
Get a little closer to the mic.
Yeah. Good morning, everyone. So this actually is I'm going to talk about 3 things. There's an update to the use cases draft, compatibility standards. This actually refers to what Thomas just mentioned, which was a question raised in IETF117 about how SAT be related to the ISO 20022 standard. And finally, originally we were thinking we'll maybe add some text in the use cases draft, but finally we decided to add it to the architecture draft. So I'm going to talk about that briefly here. And finally, I'll close with the mention about an ongoing implementation in a popular interoperability blockchain and DLT interoperability system that will hopefully provide a reference, a template implementation, as well as a software toolkit for anybody who wishes to use SATP for their purposes. So the use cases draft update, this is, we made some updates around CBDC. So there was some discussion on the mailing list around CBDC and what more we could say about it. And this text on decentralized finance and central bank digital currency. And particular central bank digital currency, there are a bunch of different scenarios which involve interoperability across different networks involving asset movements, and therefore, and it's actually one of the most compelling and near-term application of SATP and gateways, because lots of governments now are experimenting with CBDC, and they're going to need some kind of a standard secure protocol that enables interlinking of different networks, enables the movement of assets in a safe manner, which at this point, bunch of different ad hoc solutions are being worked out. So I'll mention that briefly. So decentralized finance, or DeFi, is just a new financial paradigm that leverages distributed ledgers and blockchains to offer different kind of financial services like lending, investing, etc. Primarily, it focuses on the crypto area, but really you can think of decentralized finance as anything involving financial transactions that are occurring in a decentralized way, without involving or without relying on a traditional centralized intermediary. And there is a link here. There's also a bunch of other references in the draft, if you see the use cases draft. So scope for the world of finance, DeFi offers architecture and protocols that are built on smart contracts, on blockchain, etc., and digital distributed ledger technology. CBDC, central bank digital currency, is a particular application. It does not have to be decentralized, but as it turns out, it mostly will be. I have a slide coming up that shows the landscape. So what is CBDC? It's a form of tokenized cryptocurrency that various central banks, or in this country, the Federal Bank or the Federal Reserve, are experimenting with as the digital equivalent of traditional central bank issued money. And this is money that only the central bank or the Federal Reserve possesses sole authority to mint and issue, and it can be used by other banks and other financial institutions for interbank settlements, as well as for retail purposes. So there are two categories. I'll mention that in just a minute. So why CBDC a compelling application? If you see the map of the world, this is actually 1 year old, but you can see lots of governments around the world, including cross-national organizations like the EU, which have been experimenting with CBDCs. And out of, as this says here at the bottom, 23 out of 93 CBs have decided on blockchain-based infrastructure. So most of these, or many of the most prominent experiments here, are going on top of distributed ledger technologies. And this CBDC is not just about building one big distributed ledger network. It actually involves multiple networks, as I'll show you, and as is written in the draft. And that will actually require the movement of assets, where SATP is going to play a key role. There's just an example at the right, which involves a CBDC experiment that I was involved in helping build, which involves interoperability between two different networks. Those networks are built on permission DLTs like Hyperledger Fabric and Corda, and it involved use cases around moving assets, sharing data between different ledgers, and exchanging assets. So why do we need multiple networks for central bank digital currency? It's because CBDC cannot be managed by just one single system or ledger if it has to satisfy the performance and scalability metrics that we're going to need for a system of that importance, which involves both settlements as well as enabling people to conduct retail transactions. So there we will encounter two different categories of CBDC. Broadly speaking, there's a wholesale CBDC, which facilitates interbank and settlements and cross-border settlements. And that kind of CBDC is available only to banks and other major financial institutions. Whereas retail CBDC is something that refers to a currency that is fungible with wholesale CBDC, but it's available to the public and can be used as a digital form of cash. And it's can be used as also a substitute for legacy payment mechanisms. So what these different categories entail are, they will necessitate the deployment and use of different kind of networks. Some networks that manage wholesale CBDC, others that manage retail CBDC. Some are going to be public, some are going to be private, built on permissioned blockchains or DLT technologies. Different architectures have been proposed for this, and the one that's talked about mainly in the use cases draft is the one that is most popular, which is two-tier or indirect, but there are also direct and hybrid models. I showed the slide in the previous IETF meeting as well. This is the two-tier architecture. You have a wholesale CBDC network, which involves the central or the reserve bank and various commercial banks maintaining accounts. And you can have smart contracts or business workflows built on top of that. But then in the lower tier, you have different retail CBDC networks, each of which have one or more commercial banks and as well as end users, and they can manage currencies for transfers and retail payments. And typically, they'll also have the central or reserve banks as auditors on those different networks. The use cases for SATP involve CBDC transfer between wholesale and CBD and retail networks, or between two different retail networks. And what we added recently is a use case on multi CBDC. So thanks to Thomas for proposing this use case. CBDC is a national financial instrument, but they must also facilitate cross-border payments and interbank settlements that are that are global. So two possible solutions. One, you can have a multi CBDC ledger, a shared CBDC ledger containing multiple CBDCs or facilitating exchange of CBDCs, and that will have the potential benefit to improve cross-border payments and also protect monetary sovereignty without forcing the different countries to become part of monetary union. So you can have a common multi CBDC ledger, but in order to be able to transfer CBDCs between two different countries, you will need to transfer from a wholesale CBDC network to a multi CBDC ledger or back. So that requires a protocol like SATP. And or in a different kind of solution, you can have a direct exchange between two different wholesale CBDC networks as well. So something that Andre suggested on the mailing list. So SATP across yeah.
So we've got a person with their hand up. If we could just
Okay.
take a question before we move on.
Sure.
Hi, my name is Chunchi Liu. I'm from Huawei, and I kind of have one simple question. So, in the use case, you said there will be like a interoperability between the CBDC and the DeFi applications. So, but until now, it's more like a simple exchange of CBDC between different countries and different jurisdictions. So, when it comes to DeFi, it's actually it's a different problem, right? It's actually something more like financial business related, something like liquidity mining, and you actually kind of giving out loans and getting interest back. So
yeah.
I'm not sure. Like I just want to clarify. So I don't know. Could you like clarify how do you actually use this SATP to use SATP? Sorry, to enable like DeFi using like CBDCs.
Right. I know Thomas wants to say something, but if you heard West mention a few minutes ago that the charter for this particular, or the scope of this charter for SATP currently is very, very narrow. There's a lot of things we want to do in this space. SATP is defined narrowly for the purpose of moving an asset from one network to another. If you look at the architecture draft, we actually have a broader spectrum of use cases that are, or interoperability modes that are defined there, but most of them are at this point not in the scope of the charter, and many of those other modes will actually solve different problems related to DeFi.
Right.
Thomas, did you want to help answer that question? Okay.
Specific example. So let's say you have a closed private network, and I have my assets there. Let's say call it some kind of a currency. So I have liquidity. I have 100 million there, and I go out of the network, and I want to go to a bank and borrow money. I want to buy the Picasso in your basement. Okay. And so you're going to say to me, well, show me that you're liquid. Like, what's the point of talking to you? If you say you have 100 million, show me. And so I will say, well, talk to my gateway. So you're going to hit my API and at one of the gateways, and the gateway is going to extract the evidence, the liquidity and it's going to issue a claim, a signed claim saying, we attest that this guy with this identifier has 100 million in tokenized cash or tokenized government money. So you need a gateway, and that's one of the modes that Rama is talking about. But right now we have a draft explaining all of that, but it's not a working group item. Okay. Yeah. So, but that's the point is that all the DeFi stuff will face an additional hurdle when the network is closed, private completely. Not everything is going to be permissionless and wonderful like Ethereum. So we need to prepare for that kind of sort of situation and we're using gateway as sort of a paradigm to sort of explain that.
Yeah. So just from my perspective, like DeFi is a little bit more complex.
Yes,
and
yes.
Just simply exchange things.
That's
so
right. So atomic swaps is not going to work. It's going to get very complex.
Okay.
Because if you want to do atomic swaps, one network is private, one is permissionless.
Right.
We're toast.
All right, so let's let John
Go ahead.
comment, and please do remember to use the microphones. We do have people remote that can't hear you if you're not near them.
Yeah, I'm John Levy. This may be a dumb question, but if you have CBDCs in different countries, they're going to be different currencies, and they're not going to be worth the same. You know, and the way it works now is like, you know, the Fed basically offers accounts to, you know, to the Swiss central bank, and and at no point do the two different currencies actually touch, you know, except sort of in the vaults. So I don't understand how the way that works relates to what you're talking about here. I mean, like, you can't, yeah, in the absence of a gold standard, you can't, yeah.
That's a good question, actually. I was hoping Martin would be on the
Closer to the mic, Thomas.
So the quick answer to that is the quant guys, and I'll speak loosely on behalf of the quant guys. Claire, please beat me up if I say something wrong. But they've shown an actual working demo where there is a network that connects up to a CBDC network to do the payments and settlement, but the actual asset exchange is on a different token network, right? So the CBDC is used only for settlement. Now, to answer your specific question, that's why they're talking about multi-CBDC networks, right? But I understand. So this is the whole question about, is the US dollar going to be, you know, yeah.
If I may,
yeah.
So there's a different conversation between how FX would work between CBDC to CBDC settlement and the SATP protocol providing the rails in which that can happen. So absolutely, you are right. In a normal sense, two CBDCs don't touch, but you do still need to manage liquidity when you are trading CBDC from one currency to another. So you need to manage the liquidity. You need to make sure that there's no double spending. And that's all out of scope, unfortunately, for the first version. But those are the sorts of rules and the sorts of conditions that would be handled at that stage between those messaging, between the FX, between the liquidity providers. But what the SATP and Rama's use case is to highlight the kinds of things that would benefit from having a secure asset transfer protocol in place to securely be able to interact and transfer digital assets between one network to another.
Yeah, no,
So
with one sentence and I'm done, which is, I totally get that. I guess this would be more plausible if you at least gave us some hints about like where the FX plugs in around the edges.
So putting my chair hat on, I think what we are hearing is that this is actually a difficult use case with the envisioning of the current charter, because the current charter is really, I have a fixed solid asset that will not change as it transfers from one network to another. And this use case is, you know, or the use case of multiple currencies is very much outside the scope, because we are sort of prohibited from working on, well, we actually want to mutate this asset as it gets transferred, right? So we should put a note. So there's two options, I think, and it's up to the group, not me. We could remove, you know, said use case, or we could put a note in said use case saying, you know, this is currently out of scope, and these are the missing requirements that the SAT working group is not currently working on, but, you know, will be in the future. So read this in the context of it won't work today. Does that make sense?
Just to quickly add to that, there are experiments that different banks and companies are doing. The one example I mentioned a couple of slides ago on the Bank of France and HSBC that they did with us at IBM, it involved trying to move currency or exchange currency between two different platforms. Actually, it was an exchange scenario, not a move, but that involved two different currency exchange, an atomic currency exchange, both in different denominations. So these are things that companies are experimenting with, and they're trying to make it more decentralized when the current lay of the land is not that decentralized. So they're just testing the waters out right now.
Okay, yeah, thank you. So
just
we'll
to
move
call
on.
out, we've got 5 minutes remaining. We have already gone over the allotted 15, but as Thomas finished early, just just in terms of being able to cover off everything you wanted to cover off today.
I'll be quick. Thanks, Claire. So this actually, we've already mentioned this, a question raised by John back in the previous IETF about how SATP differs from the ISO 20022 standard, and why should we not instead just use that standard for the use cases that have been described in the draft. So we are aware of these different kind of standards, but the clarification we've added in the architecture draft is that the scope of SATP is defined quite narrowly and precisely, and it also is defined in such a way that it presents unique challenges that these different standards do not even attempt to satisfy. They serve a different kind of purpose. And the intent of this working group is for the SATP protocol to be compatible with other standards, and specifically to not preclude the use of any other standards for aspects of asset management that are not within the scope, like in stage 0. So stage 0, because it's not within the scope, and where we still need different systems or different networks to agree on some things, we have scope for bringing in existing standards to allow those two different networks to talk and negotiate. So the ISO 20022 standard is, I'm not going to go into this in detail. It's a global comprehensive unified standard for financial messaging, and what it does is it allows two different systems to communicate requests or intents to each other, and it also specifies the syntax for message construction using XML, JSON, and ASN1. This standard provides communication interoperability, the ability to communicate information in an unambiguous manner across system boundaries. But what SATP is doing is something more, or something different. Interoperability among networks that are managing digital assets involve more than just communicating desire or intent about something. What we want, and this is described in the architecture draft, is that we need asset properties to be enforced at a cross network level. And what that means is that if you have a standard for communication interoperability which talks about syntax and semantics, that's by itself insufficient. SATP requires two different systems to carry out state updates in concert to achieve the required outcome. That is, an asset has to disappear from one network and be created in a different one. So ISO 20022 does not actually solve that particular problem. And by the same token, SATP is not trying to create yet another standard for financial messaging. So we have clearly mutually exclusive scopes. They can play complementary roles in the asset management ecosystem, and we can leverage the ISO standard for asset descriptors and context negotiation in stage 0, and the various functions that are listed here, they are also described in the architecture draft, if you can read them. Any quick questions on that before I just touch upon this? Yaron?
Yeah, so this is all good, but I don't understand the interoperability goals. So do you have in mind an ISO 20022 profile of SATP, and those gateways will be interoperable, or anything else?
Not at this point. I think how we can leverage ISO 20022 in SATP is the stage before the stage 1 that Thomas was talking about, stage 0, where two different systems are just coming into contact and they decide, okay, somebody in my network needs to send an asset to somebody in a different network. So how do you even start the process? How do you even discover, or how do you describe the asset that somebody wants to send? How do you describe what context that asset belongs to, what business process that asset belongs to? So there we can use ISO 20022 messages to get them to communicate, and that's particulars of the asset profile, particulars of the business process that the asset is being governed by, and then move on to the actual SATP protocol. So that's
so my question is very concrete. You're having a hackathon and you want to prove that the protocol is complete enough that you can get interoperability between G1 and G2. Those will need to speak both SATP and ISO 20022, I suppose. Otherwise, there's no interoperability.
So if I may, in the IETF, we often divide things into different pieces. So there are one of the discussions is that this actually came up, I think, in one of the last IETFs too. I personally view the SAT protocol as the negotiation process. How you encode the messages and, might be doable with the ISO framework, right? So we haven't talked about, there are many protocols in the IETF. There might be multiple encodings, right? Some things accept JSON, some things accept XML, some things might accept, ISO formatted XML. We haven't gotten down into the negotiation of, are we going to support multiple different types of messaging protocols? So that's an excellent question. I think that nobody in this working group has gotten there yet, is what it comes down to.
I probably should.
But we will have to go there. That's the important takeaway. Yes. So, all right.
Thank you.
Is that your last slide too, or?
This is my last slide.
Okay. You want to talk really quick?
I will. So we have an ongoing project on implementing the SATP protocol based on the specification SATP core, and both Rafael and I are co-mentors of a developer who's sort of temporarily hired by Hyperledger. Hyperledger, if you don't know, is a foundation that governs various blockchain and distributed ledger open source projects. And they offer an annual sort of a mentorship or internship program. So this is the system described on the right, or illustrated on the right, is Hyperledger Cacti, which is a flagship interoperability project under Hyperledger. And it consists of these modules called the relays, which we are trying to fashion as SATP gateways. So they will be conforming to the standards that are described in SATP code. So I'll close with that.
All right, thanks very much. One other, with my long-term senior IETF hat on, one of the things that we do in the IETF is when we have multiple options, so multiple encodings, multiple things, we almost always mandate one as the one that you must support. That's the way we get interoperability. Every gateway must support this flavor of JSON or whatever it might be. The rest of these are optional and you can negotiate that, but we always have the ability to fall back to one that everybody must support. Just future thought for this working group. Ned?
Ned Smith, Intel. So I didn't see in any of the use cases where you gave some attention to privacy. So I'm a little concerned that as a gateway that's exchanging a set of claims and attributes, that there aren't some claims that in one network might be defined as being privacy sensitive, but in another network it's not privacy sensitive. And you may be, if you're not tagging that information in some way, the other gateway might not treat it appropriately.
Thank you. Yeah.
All right, thank you very much, Roma. We will go on to Rafael on the crash recovery, which should be another good discussion.
Actually, if I may answer to Ned's concern on privacy, we are currently exploring what are the privacy implications of interoperating a private ledger against a non-private ledger, so a public ledger. And there are some factors that we can weight here, so such as the indistinguishability of identities, the confidentiality of the transfer itself, and effectively there are a few methods to promote privacy across ledgers, but it depends a bit on the use case. But we're looking onto it.
Remote.
Thank you. Hi folks, I'm Rafael. I've been working with Thomas and the rest of the group for a while now, and I've put my focus on crash fault tolerance and session resumption, which we believe it's a fundamental part of the protocol, so we can guarantee that the protocol is live and safe. Right, so gateways are software systems, and being software systems, they can enter faulty states for a variety of reasons. The point here is that sooner or later, a gate will enter a faulty state, and it can have repercussions on the right operation of SATP. So when a gateway enters a faulty state, it can produce alerts and errors. So there are faults that can be recoverable by sending the input or the output to the user. The user can, the user being the counterparty gateway. The counterparty gateways can act upon those faults, and the protocol might be resolved by itself, right? Other errors are more catastrophic, causing gateways to crash. So depending on the phase of the protocol where the gateway crashes, this might have important repercussions on the safety of the protocol. So for example, if a gateway crashes in the middle of an asset transfer, which is a process that involves transactions against distributed ledgers, then we might have a sort of double spend across ledgers, which is something that the protocol states clearly that should not happen. So to address the possible crashes and the possible failures, we need a strong logging mechanism and a recovery procedure that allows gateways to recover its state and continue the rightful execution of the protocol. For this, we have two databases. The first one is a state database where every gateway persists every step of the protocol locally. And we also have a distributed public database that is used for non-repudiation and decentralization of the process. So we encompass these two different databases on one log storage API so that the gateway can issue log write requests onto its database or in the decentralized database. And these logging procedures and recovery procedures are depicted on our gateway recovery draft. So this is a schematics of how the logging procedure works. All the logs are written ahead, meaning that before the gateway executes an operation, it will write the log entry that operation will be executed. So this log entry essentially has the stage of SATP, the specific step within that stage, and the process. A process or an operation is what specifically the gateway is doing. So the gateway might be about to execute a specific step of the protocol. It might be executing that specific step at that time. It might have concluded the execution, or it might have caught an error or a fail. This is the example for the transfer commands phase. So let's say it's stage 1, step 1, although we moved it to stage 0. When gateway 2 communicates to gateway, the gateway 1 communicates to gateway 2 that the transfer commands should be initiated, the gateway 2 writes the intention of executing that step within its log storage API, right? So in step 3, the intention of executing that step is showcased in the log storage API, and then the phase itself, it's executed on step 4. Upon execution, gateway 2 writes that it has successfully executed that step, and then it communicates the result to gateway 1. So here we are implicitly assuming that we are good to go for the next phase because we received an answer from gateway 2. And this logging procedure allow us to be sure of each step of the protocol at any time, such that if one of the gateway crashes, we can retain or recover the state that we were currently in. So how do we handle crash faults? Well, we have two scenarios. Faults that are non-critical and faults that we consider to be critical. The non-critical faults happen when gateways are communicating, but they do not interact with the external system. So for example, the negotiation phase. If one of the gateways crash, well, it's not much of a bummer, right? It will recover and keep the negotiation going on. It's okay. However, when a gateway crashes in the middle of a transaction with decentralized ledgers, then we can have a bigger problem because those transactions are not easily revertible. If we have a centralized database, an operator can come in and revert the transaction. But if we're dealing with decentralized ledgers, then the procedure is not as simple. By the way, feel free to put any questions during the presentation. Now, gateways are assumed, we consider two recovery process or models, the self-healing, where the gateway recovers by itself almost magically, or primary backup. We choose to standardize or to explore the primary backup because it's more sensitive, more aligned with the real world implementations. And in this model, when a primary gateway crashes, it will be replaced by one or more gateways that will act as backups. So there needs to be a mechanism for gateways to agree on who can replace them in the eventuality of a crash. Right? So depending on if we have crashes on that are non-critical or critical, we might just resume the protocol, abort the protocol, or roll back the protocol. Rollbacks are essentially the implementations for recovering faults that have issued transactions against distributed ledgers. So we need to define what is the state of our gateway, the state that the gateway has to have in order to be able to recover. Essentially, we save the session ID, the gateway is involved in the transfer, of course, the transfer context, the stage, the step, and the operation. And also, the trick is here, the rollback logic. So the rollback logic is dependent on the specific step of the protocol, and it contains the guidelines or the instructions for recovering a crash that happens in that phase. So for example, if a gateway crashes after locking an asset on a source chain, the rollback logic will tell that we should issue a transaction with the opposite effect. We now give an example of a non-critical crash, which would be, for example, in stage 1 with the transfer proposal claims. Let's say that gateway 1 sends message 1.1 to gateway 2 and then crashes right away. Gateway 2 will process this message and execute its part of the protocol. And then when it returns the message, it will face a 500 or a 503, or it will simply not have an answer because gateway 1 has crashed. So we implement two timeouts. The first timeout is when the gateway 2 tries to communicate with gateway 1, and if the timeout expires, it will retry the message a number of times or against the timeout. When that second timeout is expired, then we issue the crash recovery procedure. In more detail, we have the transfer proposal claim that it's sent to gateway 1 and then to gateway 2, sorry, and then gateway 1 crashes. So what gateway 2 does is it writes the logs that it's going to execute that phase according to what we've explained. It executes the transfer proposal claims, and then it sends it back to the first gateway, but it gets no answer, or it gets an internal error. So the first timeout, the gateway 2 will try to send back the response to gateway 1 on a hope that gateway 1 has self-healed and will be able to answer accordingly. If this timeout expires, then gateway 2 assumes that gateway 1 has crashed, and it will wait according to our protocol. This has liveness implications, but we are assuming that the primary backup model is in place. So eventually, a backup gateway will take the gateway 1's place. So when the backup gateway comes online, it initiates the recovery phase. It sends a recover message to gateway 2. Gateway 2 tries to compute the state that gateway 1 has missed because it didn't receive the original message, and sends a recover update message with that updated state. Gateway 1 can then parse this decentralized log for as an extra safety measure, and update its local state according to what gateway 2 has stated. Right, and after that recover success message, then gateway 2 might or can send the original message to gateway 1 and resume the process. So all in all, this has a few steps. The gateway 1 recovers from the crash. Gateway 2 helps computing the latest state gateway 1 has missed. Gateway 1 updates that state, and then they continue the protocol. This avoids starting the protocol from scratch. Of course, that if gateway 1 does not respond upon the second timeout, then gateway 2 might decide that gateway 1 has crashed indefinitely and it can abort the protocol. So this is a safety measure against gateway 2 waiting forever. In practice, we assume the primary backup model to hold. In theory, I mean, but in practice, we should have this timeout. Otherwise, we'll have liveness implications. In case of an abort, then the session is crashed and it needs to start over. That was an example for a non-critical crash. For a critical crash, we'll take the stage 2 phase where we have a lock assertion, and that's the outcome of locking an asset on the source blockchain. So gateway 1 sends the lock assertion and crashes right away. Gateway 2 will actually do the lock assertion broadcast and compute a receipt, and it will send the receipt to gateway 1, but gateway 1 again does not answer because it's crashed. So the procedure here is quite similar. So we have the crash, we have the computation of the result and the respective write log entries that are omitted for space purposes. It sends the answer back, but there's no answer because gateway 1 has crashed. And now we have the same procedure. So we have the first timeout that does the retries, and then we have the phase where gateway 1 recovers and does exactly the same thing. So for critical and non-critical crashes, the procedure is the same. Except that if the gateway 1 does not answer in time, then we initiate a rollback instead of an abort. So if the recovery is successful, then gateway 1 just computes the current state it should be in and executes the protocol. Otherwise, a rollback is issued.
So if I may really quick, I assume in that failure case that also is not just from a timeout, it also occurs when, say, gateway 1 says, I can't recover because my log is dead too. It was on a spinning disk that is now no longer spinning or something.
Exactly. That might be the case. So if gateway 1 has, imagine, corrupted logs, or it's not on the condition to recover, then that recover message will actually be an abort message to gateway 2. And the protocol would be, in this case, not aborted, but rolled back. This rollback might be executed by gateway 2 if possible, but might be cases that gateway 1 needs to do the rollback by itself when it recovers. So this might enter a state that's sort of a heuristic state where we need manual intervention to solve this problem. Namely, in the state where gateway 1 needs to conduct the rollback and gateway 1 cannot conduct the rollback because it's crashed.
Okay, it looks like we have one question from...
Hi, Chunchi here. Sorry, just one question about the recovery of the gateway 1. So consider like after the gateway 1 has made several like attempts or some claims, and then and this gateway 1 failed, and some backup gateway in the gateway 1 side wants to take over. So the thing is, the context of something that or exact action that the gateway 1 has actually done must be kind of retrieved out of the crushed gateway 1. So if this gateway 1 is completely crushed, it's not just networks thing, it's just like a completely breakdown, then this kind of what have gateway 1 has done, that thing is kind of trapped in this broken computer. And it's, how do you take it out?
That's an excellent question. And that's true. So if your question assumes that the state database is lost is lost with the gateway, right?
Yes.
So the gateway crashes and the state database crashes as well, and we cannot retrieve it. But the assumption we make here is that this state database is replicated in the primary backup model.
Okay.
So the way it works is for every transaction that the primary backup does, the primary gateway does, we update the state database.
Okay.
And this state database is replicated to the backup gateway. So the backup gateway is not offline, it's online along with the primary gateway.
So you kind of assume a very strong synchrony.
Yes.
Okay, cool.
Thank you for your question.
Yeah, John Levine, I have sort of a meta question,
Okay.
which is what you have here is an extremely complicated set of interacting state machines. And as far as I can tell, they look okay, you know, but I look at blogs and see where tiny bugs in DeFi state machines cause horrible problems. I'm wondering if you tried to do like formal methods to make sure you don't have any arcs to nowhere.
Yes, that's future work for sure. That would be the next step. Yeah.
Okay.
We'll define the messages, the specific schema, get right what we need to do, and then definitely we need to employ some formal methods because this has very subtle bugs that should catch.
I mean, like you read I'm sure we all read Molly White's blog, you know, like I don't want to see this on Molly White's blog.
Okay. Well, we could even consider the bug if what happens if gateway 1 sends a message, crashes, and then gateway 2 crashes, right? How would the rollback work there? Yeah, those subtle bugs, we need to think about them a bit later on.
Yeah, so I inserted myself in the queue for two purposes. One, I'll start with a statement, which is there's a IRTF group called Usable Formal Methods Research Group. They are just spinning up. They're literally had their second meeting, I think, yesterday. They are looking for test cases to apply their methodology, and not only that, at IETF117 is next, right? They will probably have a tutorial on using some of the tools. So it might be a 3-hour tour. It's Usable Formal Methods Research Group, UFMRG, and it's part of the IRTF, which is a research group. So they're looking, longer term out, but they're considering all sorts of protocols to evaluate. But my question that I was going to ask, which is the second part, is how much of this aligns, the technology for doing transactions, have been well associated with database, and the whole, ACID compliance comes long before this working group. How much of this aligns with what other people have done that is, proven to be a secure mechanism for doing, reboots and things like that?
Right. So we're using pretty common techniques, crash fault tolerance techniques from the database literature. We know that we need to align these techniques from distributed systems with formal methods to create a more robust protocol, crash recovery protocol. The working group that you suggest, I think it's a great first step to start seeing what people are doing in real world protocols and venues such as the IETF.
Great. So I will say that the reason that the research group exists is that formal methods have been around for a long time, but they're not usable. They're very hard, to do these proofs. So the goal of this research group is to make it so that, people like us that may not have much background in formal methods, I don't, might actually be able to use these tools in order to actually help us. So
we actually considered briefly to use TLS or something more in the cryptography research area, like universal composability, to model these protocols, but soon we realized that it would take a lot of work for a protocol that's likely to be changed considerably in the next few months. So as of now, we will do this as future work. All right, great. So example rollback logic for the lock assertion step. In the lock assertion, we basically have a lock or a burn on a source chain, and we need to unlock it or mint it on the target chain. So there's a typo there. So the rollback logic to undo the lock is essentially a transaction against a distributed ledger that undoes or undo that lock. Right. So the input would be the asset to be unlocked, and the output would be a bit, success or fail. So this is a quite simplified version of the rollback logic. We've actually implemented this on the first open source SATP implementation that's available on Hyperledger Cacti. So you can check the code and see how is this implemented. There's some discussion items that we can have around session resumption. So should session resumption be explicit or implicit? Right now we're considered to be implicit. So the gateway 2 expects a recover message from a crash gateway right away. We might want to have a short negotiation phase on how the recovery will be done. We can also embed this on the profiles. So having a crash recovery profile on stage 0 that defines the gateways that can be backups, the specific parameters of the recovery, and so on. Right, and the second item I think aligns very well with John's concern, which is what happens if we have subtle bugs that will invariably happen, right? There's a few solutions, a few ad hoc solutions we can create and incorporate within the protocol, but to really grasp the very subtle bugs that will appear, we probably need to use some formal methods. Wes, how much time do we have, please?
You started a little bit late because we are letting the primary presentations run long a little bit as they're important. This seems important, so I think you probably have another 9 minutes or so, ideally.
Right, very good. Another discussion which is more related to the use case would be, should we consider a burn mint protocol or a lock and lock protocol? And this is a discussion that's ongoing on the interoperability community, specifically in the blockchain world. We might consider to enforce a lock and lock or a burn mint in the protocol, or probably that will happen, would be allowing application developers to choose one of the two models.
Dimitri?
Hi, Dimitri, Apple. It's very interesting. Couple of questions to clarify my understanding. First, that asset transfer, is it a complete transfer from one system to another? There is no copying? Okay, got it. So, and the lock is universal lock, which means retry, delete. So you just lock it and no one can do anything to that resource. So the question, what is the size of the asset being transferred? Can it be large? And if it's like gigabytes, 100 gigabytes, can it be the case?
Okay, so there are no real asset transfers across blockchains. Blockchains literally do not talk with each other natively, at least most blockchains. Some blockchains have a modular construct where you can create instances of that blockchain engine and they communicate with built-in interoperability protocol, right? But for the majority of blockchains, the transferring an asset is really not transferring an asset, is locking an asset on a source chain or making it unusable and unlocking a representation on the target chain. So that representation is just a string. It can occupy as little as 32 bytes. It depends on the asset profile definition, really, and the implementation on chain. But typically it would be an entry on a table, so not very storage consuming.
Okay, makes sense. Thank you.
You're welcome. right? We're almost done. Error messages. So for situations where we do not have crashes, we might have error messages that are communicated to other gateways. So other gateways, the counterparty gateway can try to resolve the error and keep the protocol going. And we can have errors across all the steps of all the stages of SATP. Some of the errors, before I actually go to the errors, we have a schema for the errors. So the error type, the error codes, the description, a proprietary attribute where the gateway operator defines a custom message for the error. And we essentially define the different errors across the different stages. This is ongoing work. Of course, there are many errors that we still haven't discovered or thought about, but few examples are badly formatted message, an ACK mismatch, asset already locked. Then we have errors that are specific to the distributed ledgers we're transacting against, and so on.
So we've got a question or hand up from Dimitri, if I may.
Is that an old hand?
It may be an old hand. I thought I saw it go down and come back up again.
Must be old.
Oh, and we've got another one just come up now. So if we could just take a moment.
Yeah, I'm sorry for too much questions. The question I'm having is like intuitively, like burn and mint are actually dangerous actions compared to lock and unlock. So I understand like lock and unlock, it actually could be you consider from a honeypot attack, right? So that's a kind of individual level scam or some kind of attack. But if you like make it like a standard and make mint and burn, that kind of like a normal procedure that actually could jeopardize or like harm the whole system. So it's like you compare like the pros and cons actually. So I want to like know your clarification more clear, like why burn and mint is more secure, more preferable than the lock and unlock.
Yeah, that's a great question. We're not stating that burn and mint is more secure inherently than lock and lock. They have their own security models and they depend a lot of on the different implementations. So the trick here is that some blockchains, namely side chains like Polygon, they peg their state onto another chain, for example, Ethereum. The way you send tokens to Polygon is doing this lock and lock mechanism. So in Ethereum, you lock, and actually on Polygon, you mint. So it's a hybrid between burn, mint, and lock and lock. You can burn and mint the tokens in Polygon at will. Well, dependent on the rules of the lock and lock. Meaning that if you accidentally mint an asset on Polygon, you can just burn it because those rules are embedded in the protocol. Now, for blockchains that do not have those rules embedded, like Ethereum, you cannot mint Ethereum natively on a bridge, right? On a bridge use case, but you could mint cryptocurrency natively if it's an ERC20. So you could have a smart contract that has these interoperability capabilities, and you can burn and mint tokens from the smart contract instead of from the chain. You couldn't do that with ETH unless there's a hard fork that adds support for it, but you could do that with specific assets. You would have to change. You would probably have to create a new standard for assets that have those capabilities. Like Circle. Circle is working on providing that capability for one of their stable coins.
So this is one of we've been talking about this for 2 years because the problem is there's so many types of networks, blockchains, and we don't know ahead of time what type of mechanism they're going to use. So in the earlier versions of the draft, we just say disabled. The asset has been disabled, like because we don't know, is it going to be locked? Is it going to be escrowed permanently? Like what happens? And this is one of the things that's out of scope for us. We just say burn and mint.
Yeah.
Disabled, enabled, or whatever the language is.
we consider it as an implementation detail, let's say, how the asset is disabled. It could be burned or it could be locked. The specific mechanism to do that and the logic behind it is handled by the application that uses the gateway and not by the gateway itself.
So yeah, just give me a comment. So I'm just kind of concerning because mean and burn could affect the circulation of a currency in the ecosystem. So
that's right. That's right.
Note that one of the preconditions of this group was that there is likely a legal agreement between the two networks for how they agree, to handle things, and that maybe they fall back to a court system. I don't know, but Claire. Oh, Claire was going to say the same thing I did. Okay.
So exactly the same thing. That is for the participants and for the individual networks to deal with. The term we use is designed separately to the implication on the network. And also we are actually at the last 5 minutes now, just to kind of call out the time slots.
Right. Thank you. So yeah, that's a very interesting question, and I think it gives grounds for lots of discussion how we handle this. Right, we're finishing. So a quick update on open source implementations. We have relatively stable SATP implementation on Hyperledger Cacti. It's a bit outdated, meaning that it's following a previous draft, but we were working on updating it. And in parallel, we are implementing also in Hyperledger Cacti. Rama presented it, an alternative implementation in a different programming language that has a more decentralized component powered by the project previously called Weaver, now integrating Hyperledger Cacti. All in all, we'll have two implementations, one in TypeScript, one in Rust, correct? Yeah. And these will allow to further test interoperability against gateways. So having multiple implementations is a good idea for robustness. Next steps. Keep working on the error message definition, defining the various errors across all stages, update the open source implementations, and now I think we have another item which would be explore the applicability of formal methods for not only the crash recovery protocol, but I would say for SATP as a whole, which we could probably start looking onto it. Thank you. That's it. Do you have any question?
Any final questions before we go on to the next presentation? You're on.
I looked quickly at the draft, and I think there needs to be more clarity about the trust guarantees. For example, the security considerations says that both gateways are trusted, and that's sort of meaningless. I think you want to say that both gateways trust one another, and then you use hashes. And but you mentioned timestamps, so timestamps should also be secure, which I have no idea how to do. But if one of the gateways plays with the timestamps, I'm sure that there would be attacks. So,
thank you for that feedback. Actually, that's one of the purposes of the decentralized log storage. So when a gateway creates a log entry, it will sign that log entry and put it on the decentralized log storage, for example, hosted in a blockchain, so you couldn't easily tamper with it. So you'll have the timestamp recorded on the blockchain, meaning that a posteriori, the gateway might not disclose a different timestamp that the one that's on the blockchain, right? So we try to enforce some non-repudiation properties using this decentralized log storage. But I'm sure we can look onto it in more detail and discover other types of attacks. Thanks for the question.
All right, thank you. Dimitri, did you have one final question?
Hey, it's not a question. It's basically a comment based on the previous one. In addition to the trust between two gateways, it might be helpful to create end-to-end tunnel not just rely on TLS or use maybe hybrid encryption, HP key, to encrypt the whole conversation. It would make it more secure.
Yes, I believe we have that on the security considerations, but I'm not so sure now if it's on the crash recovery draft or the SATP core.
All right, so we are beyond time, so we're going to move on. And I apologize, I think I was mispronouncing your name. The font on the screen makes your V look like a Y on my screen. So anyway, so Dennis is up next.
So hello, do you hear me okay?
No, he's here. He's here. We're good. Yep, go ahead.
So I'm Dennis Avrilionis from Compelio, and I'm very excited now that we are a working group. I mean, I'm working with the group before even the formal acceptance as working group. So it's super, all the input that we're getting today. So looking forward to more sessions like that. So the transition, this presentation is also quite well linked with the previous comment about legal jurisdictions and things like that. So I will start presenting, it's a bit of vocabulary here about assets. So down at the bottom, you might have seen the thing that Claire presented in the beginning, which is the scope of SATP. So we have the two gateways with the two networks. Okay, there is a, okay, we use here a system because it might also have legacy systems behind the gateway. But the idea is that the asset, the instances of the assets reside inside the network. So there is an asset issuer, which is a party, that actually creates instances of assets inside the networks. And these instances, they have a ontological link as class instance with what we call an asset profile. So the asset profile is typically the definition of the class of an asset instance. And because we have this problem of trust, and in general, I mean, the computation might be dependent on the type of assets that we are moved, and eventually we have also legal restrictions and requirements in the different networks. So there should be a party, which is what we call the asset definition authority, that actually gives the definition of what is a valid asset profile, from which we can derive instances, if we are an asset issuer, that we can eventually mint on a network. So we can have the gateways transfer these asset instances using SATP. So if you have any questions, please, I mean, can stop me at any moment. So we can move to the next slide. So here it's an attempt to somehow put some semantics on what is the assets being moved between the different gateways in SATP. As we said before, there is ISO 20022. Okay, there are definitions of the semantics of financial instruments there. However, the purpose of SATP is to move assets from one network to the other. So there are some minimal requirements that we have to define on what could be part of an asset. So in the profile, we have identified some categories as I show here. First of all, the most important thing is to identify the asset. So there should be IDs, both on-chain and eventually off-chain, because we may be having assets that actually live outside the network. Typically, if we tokenize, for example, assets, we might be having legacy systems that actually hold the real asset, and the assets that we see in the network might be proxies of that asset. So there should be an on-chain and off-chain eventually IDs. And there is definitely also the possibility, if we have typically in the financial sector instruments with ISIN codes and descriptions like the key information document or prospectus, that might be things that actually belong to the asset. So we know exactly about what is the asset that we're going to transfer. Now, in terms of computation, we touch upon many things. When we negotiate the claims, potentially before SATP, there should be some capabilities that we could define at the level of every asset that have to do with the constraints in transferability, typically burn mint, for example. We should destroy the asset on one network and recreate it on the other. the way that we can trade the asset, if the asset could be extinguished or not, if it is taxed or not, for example. Other things that were also related to the CBDC use case, if there should be collateralized or not on the target network. And of course, there is also law enforcement, so the fact that we can confiscate the asset is also an important thing. Now, in terms of ownership of the asset, if we take the broad set of roles that actually are part of the business process of creating and trading assets, we might be having the creator, which is the party that creates the asset. Talking about also getting the requirements from GDPR, for example, there might be processor entities that are different from the creator. So they should be somehow defined as part of the profile, as well as if there is distribution of asset by another party or a custodian of the asset, and eventually definitely the owner of the asset at any point in time. Now, in terms of compliance and validity, there is also the fact that assets could be audited. So the identity of the auditing party, and eventually if there is a time in the validity of the asset between the issuance and the expiration, and any sort of evidence about the fact that an audit has been carried out, it is also important. And finally, there is also the reference to the jurisdiction, either of the owner, the processor, or the creator of the asset. So these are all the kind of information that we believe should be the minimum to define when we define the profile of the assets. And this is part of the negotiation phase when we start discussing about transferability of assets in stage 0, as the other presenters mentioned before. So next slide.
Just to interject, we've got 4 minutes left. Sorry, thank you.
Yes, it's a very short presentation. So now, in terms of the instance, so we say that the asset profile is class, and there is a class instance ontological connection with the asset that lives inside the instance, that lives inside the network. So in terms of what we need to process assets, is first of all, they have to have IDs, so we can refer to them universally and even across networks. They have to have a type. They must be typed, so there has to be a explicit reference from the asset instance to the asset profile ID. They have to be trackable, so if asset instances move from one network to the other, we should be able to follow the trail of the asset, so we know that it has been typically burned in one network and minted in another network. And there are also some computation restrictions. Typically, we have to have a serializable stable property in the asset. So if we take the definition of the asset instance, typically, let's suppose that this is a JSON. So if we deserialize the asset, this computation should be stable. So we should not have, typically between languages, floating points that actually make it so the asset instance string, for example, JSON string, can differ if we serialize and deserialize. Same thing about persistence. The fact that we persist and we fetch from a persistent storage the definition of the asset instance should also be something stable. So we can be sure that if we, and as the last property, if we hash, for example, the asset instance, also the hashing should be transparent in terms of stable in terms of any computing language or stack that we might be using. So although we don't impose, of course, any specific format for that, there are some interesting RFCs. So the JSON canonicalization schema, and as well as the signature, the JWS, that could be things that we can use for implementing a first version of what is the asset instance that reside inside the networks. And of course, also Rama mentioned is that we should be able to have a discovery service at some point. Of course, this is out of scope of SATP, but the fact that we can register assets and we can go to a global discovery service, it might be a very interesting service to have in the negotiation phase among gateways. So that's it.
Right.
In terms of my
Thank you very much,
presentation.
Dennis.
I don't know if you have
Are there any
questions?
questions from Dennis? I will highlight one from a chair perspective. The asset profile list has a long set of stuff. One thing that the working group needs to consider in the long runs are which ones of these are helpful versus required. As you know, the IETF has sort of 3 levels: may, should, and must. Must means it absolutely will fail if it's not included, whereas should is things could easily go wrong, and may is it's just helpful. So you should consider,
Absolutely.
in this list of that. Yogesh. And then we'll quit and shift.
Hi, this is Yogesh. My question is about quality of service. Is there any consideration of that at all? For example, say party A is trying to transfer 100 assets versus party B is transferring 1. How do we prioritize whose transaction goes through?
Yeah, actually, it's a very good question. This is orthogonal to the definition of the assets. So here it is more touching, going the direction of having some sort of semantics inside the assets. I believe that such type of considerations should be part of the stage 1 in the negotiation between gateways. Maybe we could prioritize things. I mean, if we have, bulk transfers or something like that. Also, things like, for instance, long lock periods. That's also some part of the quality of service. If you actually keep a lock and the transfer remains there, I mean, would we allow for something which is, for example, like an optimistic locking? So the first who transfers actually wins, and stuff like that. So all this quality of service is part of the stage 0, stage 1 parts of the protocol.
Thank you.
All right. Thank you. So the chairs have silently decided behind the scenes that we have 19 minutes left and 35 minutes of presentation material, but we're into the any other business section. So we do want to dive into, actually, that is the wrong one, isn't it, Thomas? We do want to dive into the remaining items, and our proposal is that we do stick with the ordering that was in the any other business, because it seemed to us that the gateway transfer initialization claims and the stage 0 transfer context came up a lot in today's discussions, and that would be good to helpful, but we may not to get to Rama's. But it's the working group's decision, so if you guys have complaints on the chair's decisions in ordering, we'd like to hear that now. Okay, so we'll let Dennis go with stage 0 then, according to Thomas's in the room comment.
So I
very much.
assume that Thomas interpreted the actually the sequence, right?
Yes, so you're on
yeah,
this
perfect.
set of slides of yours.
Perfect. So yeah, here it's the famous stage before. I mean, okay, so I have the freedom of discussing out of scope things here. The idea of stage 0 is how we establish the link between gateways. So this is an example flow of what could potentially happen before SATP. So as you see in the diagram, down in the bottom we have SATP. So this is what happens before. And when I'm saying in the gray, I'm talking about stage 1, 2, 3, as Thomas presented. So here, there's one possible flow of how things can happen. The idea is that from the application, because we have 3 actually levels, we have the levels. We have the application, the gateway, and the network. So as in, borrowing the flows from the old transaction processing theory here, we have the application to application communication. So we initiate at stage 0 the whole thing, SATP, before starting SATP sequence. When we have a client application that goes, so Alice wants to transfer to Bob. So here I have the client application Alice that goes to the gateway and say, I would like to initiate a transfer. And I would like to send that specific asset to Bob, for example. So the application goes to the gateway and gets what we call a transfer context, which is the set of claims basically that we have to negotiate between gateways. And when this transfer context comes from the gateway, so typically signed from the gateway, or the gateway knows that it is its own transfer context, the client application goes to the network, the system, and says, here is a binding that you have to do between the context of the transfer for this specific set of assets, for that specific session, transfer session. So the client application then propagates to the remote client, to Bob application, this transfer context. And similarly, the Bob application goes to the network and say, here is a transfer context, so be prepared to receive assets coming from network 1 inside network 2. And also, I'm in 6, and now as a step number 7, the Bob application goes to gateway 2 and say, this is a specific transfer context that require you to bind yourself as gateway 2 to the gateway 1. So that's where the gateway 2 comes back to gateway 1 and says, this is me, and you are going to go and do the transfer with me now. So that's actually puts together gateway 1 with gateway 2. And because the transfer context was originated by the gateway 1, then we have we're closing the loop, some sort here. So next slide. So if we see it as a set of conditions before we enter SATP, on the outgoing, the egress side, the gateway 1 side, the application, the Alice level application, knows that there is a transfer context where we can put all sets of claims between the gateway, the assets of network 1, and we know that this is a well-defined set that is going to go to Bob on the other side, to the remote application. And in terms of the network, then we have a well-established link between the set of assets and the gateway that is going to transfer them. And we know that the two gateways are bound, G1, G2. Now, on the receiver side, on the ingress side, the beneficiary application knows about Alice. The network knows that it's going to receive assets from network 1, and the two, actually, gateway 2 is bound to gateway 1. So, next slide. And this could be an example of what a transfer context is. So, first of all, we can have an ID of the transfer context. We can have a state of the transfer, so whether it is active or committed or aborted, for example. And typically making a reference back to the crash recovery from Rafael, is that we can have a session ID, but eventually we can have a history of sessions in case that we have recoveries from other sessions. So we discontinue the session, we create another one, but it's part of the same transfer context. And then there are information claims about the outgoing egress part and the incoming, the ingress part. So we have the ID of the gateway, the ID of the network, the ID of the assets, eventually some expiration, and many other things that might be added as part of the context. And this is still work in progress. And similar thing on the reception side, on the ingress side, network gateway ID, gateway 2 ID, network 2 IDs, plus eventually assets that should exist also on the other side, on network 2. And this transfer context concept is the thing that actually puts all the claims together, so the gateways can negotiate before SATP starts. So that's it.
All right. Thank you, Dennis. Thomas, do you want to add anything from your perspective and similar agenda item, or you're good? No? Okay, he's good. Perfect. Then we can give the last 10 minutes to Rama. Thank you very much, Dennis, for your presentation. And we will, we might actually almost get done in time. There you go. Those are right?
Yeah. Okay.
Oh, yeah.
Okay, so I presented a couple of slides.
A little closer.
Sorry. A couple of slides here I presented back in the previous IETF as well. So this is just food for thought, and because the question of using the gateways to query rather than to move assets came up recently. So I just thought would remind the community and maybe think about it, see if you if this is useful, and what parts of this maybe we want to standardize, and we can decide how to expand the scope then whenever the next rechartering comes up. So you can see the diagram on the left. The first use case there is asset transfer, and that's what the current SATP charter is focusing on. But if you look at the architecture draft, we also describe two other broad classes of scenarios involving assets in two different systems, often but not just distributed ledger systems. These are asset exchanges, which means which also have to satisfy the asset property of two assets being exchanged or swapped in two different networks. In blockchain parlance, you may know of it as atomic swaps. That's really what we want to solve here. But there's also another use case which involves just the ability to query, to locate and query the state of an asset, or find out about the state of a business process that's operating on one ledger from the outside. Thomas.
Actually, great. No, go ahead, because I was just going to comment on the third one, the data sharing.
Okay, so just to connect this to what you see on the right, the classification. There's another way to think about this. If you're coming from the database world, it's like if you have two different systems, if you sort of abstract them as databases, asset transfers and asset exchanges involve state updates, simultaneous state updates in two different systems, so that you need to execute an atomic transaction. So there's a bidirectional dependency between what's happening in the two different systems. Data sharing or data transfer is you read something from one system, and that triggers some sort of state update in a different system. Thomas?
Yeah, so a good example of just a comment on the third one. So in the finance sector, I believe it's called the counterparty completion risk or something. So this idea that Alice is going to sell her car, a Ferrari, and
counterparty risk, yeah.
Yes, and so the problem is that both sides are not sure if one has liquidity, has enough cash, and the other one actually owns a Ferrari. So this is where you have these sort of centralized market making sort of systems to do the matching, right? But in a DeFi world, and I'm looking at that guy over there. This may not, be entirely possible. And if it's a DeFi world with like private closed networks, then you need this third feature, which is give me evidence of your liquidity. Give me evidence that you own a Ferrari, independent of the transaction. This is just initial dialogue. This is just talking. This is no commitment. And so, in fact, it might be the case that third one, data sharing, is a core part of the what Dennis has just explained, right? The applications are sending to each other evidences of liquidity and evidences of owning a Ferrari. And in the case that the liquidity network or the Ferrari network, is closed, this is exactly the model we want. Is one side is going to ask the gateway, say, hey, give me a signed claim that so and so owns a Ferrari, and the other side will say, give me a signed claim that Alice owns $1 million. So that's just a comment.
Yeah, no, thanks for that. And I kind of omitted the main part that Thomas is talking about, which is that data sharing or data transfer is extremely useful or necessary when you have these closed networks. It's not so important in open networks, like anybody can go and query what the state of a contract is in Ethereum. But if you have a network that requires permission to view it, then you have to have a protocol like this. This is just an overview of cross-network workflows. So you can have different kind of networks which are running business workflows. Again, the blockchain parlance calls them smart contracts. They manage digital assets, and two different processes or two different smart contracts in two different networks may be interdependent, and therefore they require interlinking in some way. I don't have the slide here now, but in the previous IETF, they had that example of two different trade networks whose processes are intertwined, and therefore they would benefit from a protocol that allowed the networks to query each other. Any sort of a workflow that spans multiple networks requires some sort of cross-network operations. One of them is asset transfer. Clearly, once you decide that an asset must be moved from, it's being managed by one process in a network, but it now needs to move to the domain of a different network and a different business process. At that point, you need asset transfer. But even before that, the business workflow may have other operations to do. It may need to discover that an asset actually exists in one network, therefore it needs to be fetched into another network, and it also the process in one network needs to query the state of the asset in one network, so it decides whether or not to request for that asset to be moved. There are different things one would like to do. So a core primitive, one of the core primitives clearly is asset transfer. Another we believe is can be very important is the ability to query the state of an asset or to query the state of the process managing an asset from outside that network. And the key thing here is that that network is opaque, or it is hidden from view to external parties. Therefore, the gateway is the only way by which you can actually reach into that network. So just highlighting one point here, in addition to having a protocol or a data sharing protocol to complement an asset transfer protocol, what we need here is a proof of evidence, proof or evidence of authenticity of the state, because these networks typically are not governed by single parties. They are decentralized networks within themselves. If you're running a blockchain or a decentralized or a distributed ledger, they're running some kind of consensus protocol among themselves. So you cannot actually have some party try to proxy or try to be the spokesperson for any information that that network needs to consume from the outside. So some kind of proof is necessary so that it can also be validated by the peers running the network. So that is something that we need to take into account. And as Thomas mentioned, one of the requirements when we relate it to the CBDC use cases is the ability to request and find evidence of liquidity in the form of CBDC tokens. So yeah, move to this. Yeah, so this is actually something that we have an implementation of. In fact, the earliest implementation of this was like 3 to 4 years ago, and there are a couple of peer-reviewed publications that we have on this that talk about how to why we need to query a different network for data, and how do we do it in a way that does not require any trusted intermediary in between the networks. There's an open source implementation of the libraries within Hyperlogic Cacti. So the concept that we are talking about here,
about 2 minutes.
2 minutes, okay. It's we call them views. This is a term borrowed from databases. Just like in databases, you can define views that allow a client to query for a particular subset of a database and get something that and get a response which only reveals what the implementer of the view allows them to view. So we sort of borrowed that terminology from the database world, except here it's about one network or some party external to a network trying to view something within a network, and that network is permissioned. So we need some standardized way of querying that particular network and to identify a particular resource that you want to view and then getting a response. So the something that the requester needs to supply is some sort of descriptor. So the term we use for that is view address, and this is outlined in a draft that you'll find listed as a related draft on the SATP page. As you can see, there is it has a hierarchical structure. There's a location part, there's a ledger part, and there's a view part. So this is something that we believe if we can standardize this, then we can provide a well-defined way for parties to identify a resource or a piece of data they want within a permission ledger and get that back. Modulo any kind of policy enforcement that the ledgers want to do. This is just some samples from Hyperlogic Cacti. You can see that if you browse the Hyperlogic Cacti GitHub repository. I won't go into the details here. just last couple of slides. The highlighted part, the yellow part, is what we would like to standardize here. So the part which involves operations going on within the network, that'd be outside the scope. But the part that the gateway can handle, which is gateway receives a request for a view and then responds with a view, that's something I think is amenable to standardization. And in the view request, it must contain a view address, which is also in standardized format. And this is an extrapolation of the previous slide where you have two networks. In the previous slide, you had just one network being queried by an external client. Here you have two networks, and so you have a gateway to gateway communication. One gateway queries another gateway with a view address and gets back a view and response. So.
Okay, fantastic. Thank you, Rama. We are at time. I think today was a fantastic set of discussions. I think the authors got a lot out of the feedback presented, so thank you, everybody. For the identifier thing, we do need to make sure that we stick with sort of existing standardized ways of labeling, DIDs or URIs or something like that, but we can work through that as a working group. And thank you to Claire, who fixed a bunch of my mistakes silently behind the scenes. It was wonderful to have her remote with multiple screens and handling things in the background, including timing and everything else. And thank you, everybody, for participating. If you haven't signed in yet, please make sure that you do that before you leave. There's a QR code outside the door. And we will see you all in Prague, which is a wonderful city, one of my favorites, and I hope to see you all there. Ship them to Claire and I, and we'll take care of it.